Hey guys, this is graphing linear equations. This is section 4.2 in your book. Here's the vocabulary you will need to know for this section. You can pause this video to copy your vocabulary, or you can just look these words up in the glossary of your book. Okay, so we're learning how to graph linear equations. Our first example is x plus y is equal to 4. So our first step will be to solve the equation for y. That's going to make our other steps a little bit easier. So to solve our equation for y, it's a one-step problem. So I have x plus y is equal to 4. To solve this equation for y, that means I want y by itself, which means I want to get rid of everything that is on the same side of the y. So I'm going to be moving that x. To move a positive x, I need to do the opposite, which is to create a negative x or to subtract x. Over here, to keep it balanced, I need to also subtract x. Notice where I put it. I did not put it under the 4 because the 4 and the x are not like terms, so I will not be combining them into one term. On the left-hand side, the x is canceled, leaving me with the y. Over here, I have 4 minus x. I cannot combine them. They are not alike. This is like $4 minus a cat. Okay, so I've now solved for y. Now I make a table. To make a table, I come up with x values. These x values are chosen by you. Now, for majority of questions, I choose the same 5 values: -2, -1, 0, 1, and 2. I adjust these as I see fit for certain equations, and we will see examples of that this year, and I will explain that as that comes across. So I have y equals 4 minus x, and I now say I want to plug in a -2 for x. So I have y is equal to 4 minus a -2. Well, we all know that minus a negative is the same operation as adding. So that is technically 4 plus 2, leaving me with 6, and then just drop down your y. Y is equal to 6. So then in my table, I would put 6. So when x is -2, y is 6. And you just need to do that for all of these values of x. Wherever you see the x, plug in the next value, simplify until you get a solution, and then that solution goes in the spot in the table. So you can sit there and work out all of these for practice. If you get it, then you can just move on. Okay, step 3 will be to plot the points and then to connect them. So we all should remember how to plot points. So on my graph, I had -2, or on my table, -2, 6. So then on my graph, I would go on the x-axis to -2. Well, that was positive 2. I need to go this way, -2. And then the y value was 6. So then I needed to go up 6. And then that's where I would plot my point. -1, 5. Over -1, up 5, plot my point. 0, 4. So that is a 4 on the y-axis right there. You'd plot your point. 1, 3, 1 to the right, 3 up, 2, 2, 2 to the right, 2 up. So once I've plotted all the points in my graph or in my table, I would then draw a line through those points. As you see, that's already been done here. Draw the line. Make sure that you put arrows on the end, because this is the graph of a line. Okay, example 2, graph y is equal to -3. Well, before we had solved the equation for y. Well, it's already solved for y. Then it says make a table. Okay, so if I made a table, oops, sorry, I forgot my pen. If I make my table, so I have my X and my Y. It doesn't matter which way you make your table. You can make it horizontal or vertical. Okay, I have -2, -1, 0, 1, 2. Okay, so I'm going to plug in -2 into my equation, but I notice that there is no X. So you're probably thinking, well, where in the world would you plug in the -2? How are you going to get these answers? Well, I could rewrite my equation. Y is equal to -3 plus, well, I need an X. So there's my X. But I can't just do that because that's not mathematically sound. So think for a second. How could you rewrite this equation so that you would have an X value in it and that the equations would be equivalent to each other, where you haven't really changed the equation? Okay, if you've thought for a second, hopefully you've come up with 0x, because 0 times x would eliminate the x, leaving me with y equals -3. Okay, this is very technical. I'm just showing you where this is coming from. You are not going to have to do this each time. Okay, so if I plug in a -2 for x, I would get -3 plus 0 times -2. This is all equal to y. Order of operations says I must do that operation first. Well, 0 times anything wipes it out. So I get y is equal to -3. So in my graph, in my table, I would put a -3. If you do that each time, if I plug in a -1, this is going to cancel out again, leaving me with -3. And so on and so on. So all the y values in my chart end up being -3. So I'm going to plot these points. I have -2, -3, so that needs to go down. And then I have -1, -3. Whoops, I messed up. Let me erase. Okay, let me try again. I had -2, -2, -3. No, I had done it right. -1, -3. No, I had done it incorrectly. 0, -3. There we go. 1, -3. And 2, -3. So there's my chart. Then I would connect these with a line. Okay, and that should be straight. Hopefully you're using a ruler or index card or something. Make your line straight. And that is the graph of y is equal to -3. And you should notice something special about it. What's special about it is this is a horizontal line. Y is equal to -3 produces a horizontal line. Now I want you to think what you think y is equal to +3 would look like. What would y is equal to +3 look like? Let me see if I can change my pen color. See what blue looks like. Okay, y equals -3. The same thing if I had put plus 0x there, and I plug in a 1 for my x, I would get a 3. If I plug in a 2, I would get a 3. If I plugged in a 0, I would get a 3, and so on and so on. This produces a horizontal line. It crosses the y-axis at 3. So that's the graph of that one. Y is equal to -3 produces a horizontal line through -3 on the y-axis. So think in your mind what you think y is equal to 1 would look like. Hopefully you're thinking, oh, it's just a horizontal line through 1. If you thought that, then you are right. Okay, here we have x is equal to 2. Okay, so again, let's just look at the chart. Just for grins, when you have an equation like this, you're going to know exactly what to do. Here, this says x is 2. So I really am not able to choose my values because my equation tells me that x must be 2. Okay, so if x is 2, what can my y's be? Okay, well, I could have plus y. Well, I just changed my equation. How could I write it with a y so that it's not changed? I could put a 0 there. So, if my x is 2, what kind of numbers could I plug into y to not change my equation? Well, could you plug in a -2? Well, 0 times -2 would be 0. That would be wiped out, leaving you with x is 2. Could you plug in a -1? 0 times -1 wipes it out. Yes, again, over and over and over again. Because this is a 0 here, we could wipe out whatever we plug in for y. So let's plot this to see what this looks like. An x of 2, a y of -2. An x of 2, a y of -1, 0, 1, 2. What have we created? What kind of a line would you call this? If you said vertical, you are correct. Okay, what do you think x equals to -1 would look like? If you said it would be a vertical line through x is equal to -1, pretend that was straight, you would be correct. Okay, a summary of horizontal and vertical lines. We have the graph of y is equal to b. Don't let that confuse you. Just think of y is equal to some number. B is just the number. Y is equal to some number is a horizontal line. The graph of y is equal to b passes through the point. Okay, the x value would be 0, and then the y value would be whatever that number is, and we're going to represent that number with the letter b. So whatever that number is right there, this b, that's going to be the point it's going to go through. The graph of x is equal to a. Remember, a is just a number. If that confuses you, you can just replace that with the number sign. X is equal to some number is a vertical line. And the graph of x is equal to a, or you can think of that as some number, passes through the point. Well, x is equal to that number, which we're representing by a, and then the y value is going to be 0. Okay, basically what you found is your y-intercept, your x-intercept. This is a y-intercept, this is an x-intercept. Okay, now we're going to graph our linear functions with a domain and identifying the range. Keep in mind, domain is just simply what kind of numbers can I plug in for x? And range is what numbers do I get when I plug in my domain for x? What pops out for y? It's as simple as that. So in this question, they tell me a domain. X, okay, tell me that symbol, greater than or equal to 0. So that means I could plug in any number for X as long as I start with 0 and it's greater than or equal to it. So I could plug in 0, 1, 2, 3, 4. I could have a half. I could have a million. I could have 4.69632. I think you get the idea. In our chart, we are picking these points based on our domain. We're going to pick whole numbers because that's just going to make solving for y easier for us. But keep in mind that I can choose any kind of number in between 3 and 4, 2 and 3, 2.5, 2 3/5, whatever. Okay, but just to make it easy, we're going to pick whole numbers. So I'm picking 0, 1, 2, 3, and 4. I start at this point right here, the 0. That's going to be the first number in my chart. And then I will go up from there because it says greater than or equal to. So I'm just going to go up from there. So again, you would plug in 0 for X. 2 times 0 is 0. 0 plus 2 gives my Y 2. That's where the 2 comes from. Let's see where the 8 comes from. So I would have y is equal to 2 times 3. I'm plugging in 3 for X. And then adding 2 because that's what it tells me to do. So this is going to give me 6 plus 2, follow the order of operations, 8. Y is 8. So that's where those numbers are coming from. We're just plugging it into this equation. Okay, so once you've created your chart based on your domain, then you're going to plot your points. So you're going to have 0, 2, 1, 4, 2, 6, and my graph is going off, but that's okay. We'll just make it do. 3, 8, and 4, 10, way up there. Okay. Now, my question to you is, I need to connect these points. Am I going to be connecting them with a line? Well, if I connected them with a line, let's say I connected them with a line. Don't do this yet on your notes, okay? Let's say I connected them with a line, okay? Is this a correct way to graph this? Well, we have y is equal to 2x plus 2, but they told me my x's cannot be greater than or equal to 0. Or sorry, they must be greater than or equal to 0. So here on my line, I have this point right here with an x that's -1. Does that fit within my domain? Can x be -1? The answer is no. Remember, this line goes on and on and on and on, so I eventually will make it to x is -5. Can x be -5? No, I cannot plot any points that are not going to be on the graph. So this section of the line does not exist as soon as I say I have a domain. So I cannot graph this with a line. But notice that I've crossed out the bottom part. Have I crossed out the top part? No, because I can have an x of 3, an x of 5, an x of 1,000,000. This is going to go on and on and on and on up. That's okay because those x's are greater than or equal to 0. So let me erase this, and this is what it's going to look like. I'm going to start at 0, 2. That's going to be my first point because it says equal to. I can include that point. And then I have my 1, 4, my 2, 6, and so on, so on. I'm going to start here and I'm going to go up in this direction. And I'm allowed to go up forever in that direction. This is the graph of y equals 2x plus 2 with a domain, my restriction, my x's are greater than or equal to 0. So, have I created a line? No, I have created a ray. Hopefully you remember that from geometry from previous grades. That is array. This is what happens to my line as soon as I restrict it with a domain. Now, what's my range? Okay, remember range is what y's pop out of my equation when I plug in certain x's. So I have my smallest x is 0. When I plugged in my x, I popped out a 2. And then what happens to my y's from there? They get bigger. So my range is y. My smallest one is going to be 2, equal to, and they're getting bigger. So my range is y is greater than or equal to 2. And if you look at the graph, you see that's true. So on my graph, my y value is 2. And as I go up on my graph, my y's are getting bigger. See, your y's go up, my graph is going up, my y's are getting bigger. Oops, trying to get to the next page. Whoops, don't look at that. Okay, checkpoint. Pause this video and do checkpoints 1 through 5. If you need some help, rewind the video, rewatch some of it. Press play when you're done so you can check your work. Okay, and that should have said 1 through 4. Okay, so check your work. If you have any questions, call a friend or ask me in class tomorrow. Oh, it did say 1 through 5. There it is. There's the 5th one. Okay, a basic summary of graphing equations. You should have learned basic steps to graph an equation. Solve the equation for y, make a table, plot the points, and then connect the points. Equation of a horizontal line looks like y is equal to some number. Equation of a vertical line looks like x is equal to some number. You've learned to graph an equation given a domain and how to specify the range. We will practice this more in class tomorrow. If you need more information, look at section 4.2 in your textbook. Look at those examples. You can also visit the Khan Academy website and type in graphing equations or maybe domain, range, type in some keyword in the math section of Khan Academy. You can also look at Mr. Matuni's videos on this topic. Go to my website under links. There's a link to Mr. Matuni's website. On the left-hand side, you'll see algebra. Kind of open it up and it'll expand to give you all the sections in the textbook. He's also done videos and maybe looking at his may help him. See you tomorrow.